Hey, hi everyone. This is Manish. I'm part of Cosmos DB engineering team. I take care of partners from engineering side, and we were running a program called Azure Cosmos DB Participant Program. Every month, we are also running Scalable AI in action. This series we are running since last year, July, and the intent with this series is to ensure that we have a partner who can come and showcase their success story here, and they can enlighten us how they are using Gen AI applications using Azure Cosmos DB. And today we have none other than Jerry Hawk. He's a CEO of Datavail. Datavail is our flagship partner who is having expertise in Gen AI, and they have a very good understanding about Cosmos TV. And I'm sure that you will also see that during this session. Um, uh, just a quick note about Jerry. Jerry is a technology leader since 30 years of experience he is having, and he's known for driving growth, operation excellence, and strong partner-led customer outcome. I think this is a amazing mixture. That's what Jerry carries, and his experience towards scaling global software and SaaS-based services and services businesses. It's all going to give Datavail a cutting edge. Welcome to the show, Jerry.
Thanks, Manish. Glad to be here.
Thank you so much for your time. And without any delay, let's get started. With first and I do have some questions I wanted to ask you, and primarily to understand, your vision. Yeah, let's get started. I have one question, Jerry. So, what are the main challenges holding back Gen AI adoption today? And where does Cosmos DB creates the biggest unlock for customer and partner?
Yeah, it's a great question. I mean, we've sort of gone beyond the new phase, and most customers are looking to deploy. But the biggest challenge remains really security and governance associated with not only the data that they store, but also what they might send on to other services and other models. So we've seen a lot of concern around that. The nice thing is, if you look at where Cosmos sits, one, it's right in the center of the Azure ecosystem, right? So you've got all the security all the way back to Intra ID. You have it at the data level. You're able to adopt a governance program around it, and it's really helped to have all this functionality, because some customers, some need GDPR, right to be forgotten. Some, that's not really a concern because they're single region. But just having that capability and being able to explain to our customers, hey, this is how you can secure this and make it part of your governance all the way down at the data tier has been extremely helpful. So I think that's probably the biggest thing. I think everybody wants to deploy, and it's really getting that understanding and how you make that work within the Azure environment is really the education that partners need to do. But we've been very successful doing that. So I think it's a huge benefit and a great solution for that.
Awesome. How's Azure Cosmos DB helping you address Gen AI infrastructure challenges like scaling vector data, enabling real-time retrieval, and support high throughput workload? I think that's
Yeah, a great question. Again, most customers, they don't think about this, right? They're really more concerned, hey, how do I deploy this and get this in front of a select number of users? But if you kind of rewind the clock back, before Gen AI was really a thing, Cosmos has been around quite a while. And originally we would always use it for really high scale or really fast retrieval. global applications, and that's pretty much been its claim to fame for years and years and years. And it just so happens that the model and the way the product was designed it lends itself very well to Gen AI and frankly a lot of AI workloads. So it's sort of the Swiss Army knife of AI in general, right? Whether it be streaming data coming from IoT, where you're acting on the data in near real time, or you're doing like a global deployment of Gen AI, and you really need the performance that only this solution can offer. It's that to me is really the differentiation. We've proven the solution at scale time and time again across ISVs, across large SaaS providers. And now that we've added so much functionality for Gen AI, it's really just an extension of that. So it sort of removes the deployment bottleneck, the retrieval issues, all of the performance stuff. If thought through and in the beginning, it really becomes a non-issue. So that's something we sort of take off the table. Now, we have had a lot of customers that have deployed on other solutions that really haven't been very happy with the performance, especially when they're doing outside calls to things like an external vector DB, or they have a solution like AI search, only it's not part of the stack as it is within Cosmos, even though it's on the outside, it's within the ecosystem. So those SLAs kind of hold true. So that is really a big differentiator for the solution, and I think a natural progression of where Cosmos is going. And I'm happy to see sort of the grand scale of Gen AI and having a solution that doesn't limit us in that way.
Awesome, thanks. Next question is on the core aspect of Gen AI solution. Most of time, of course, the problem statement, and you have an understanding. In fact, defining that itself is the biggest challenge. But after that, when you try to develop a Gen AI application, scaling is the toughest challenge, so to say, in production. How did you find Azure Cosmos DB was helping?
It is a challenge. It's capacity. It's the way we can replicate and shard data across regions. All those scenarios are really challenging when you don't have the right solution at the core. And again, the thing about Gen AI that's very different than other applications is it's 100% scaled by data, right? So yes, there are query workloads, but the data side of it can get very, very large, very, very quickly. And you also have mixed media types, right? So photos and video and all the stuff that goes along with it, which becomes a big bottleneck in a lot of solutions that are out there. So again, these are scenarios that Cosmos was essentially built for. So it makes a really big difference. It makes it easier for customers to really think about, how do I secure this data, not how do I make it perform? And oh, gee, do I have to create shards of data in specific ways just to make it perform, right? So that problem goes away. So it really allows the customer to think more about, what's the best business use case? How can I get the best service to my customers? Not, geez, what are all the underpinnings that need to go along with how I store the data and where it replicates? So it's really, and again, it goes back to just the genesis and the scale of applications that Cosmos was originally built for, right? It was never built for small applications in the beginning. It was built for global scale applications. You can certainly use it for smaller applications, and it works great for that, sort of the Swiss Army methodology that I used earlier. But when you need to go big, you don't need to worry about it. It's there for you, and it basically is going to get the job done.
Exactly, and I think there's always a gray area where you don't know,
Right.
and someone supporting at that point, I think that's a blessing, altogether. And glad that Cosmos TV is helping. So I know you have interacted with many customers, many enterprises across the world, and you have seen so many implementations happen and happening right now. So what kind of business outcomes you are seeing right now using Cosmos DB as part of your Gen AI stack?
It's yeah, it's pretty comprehensive. So if you look at, I'll probably talk a little bit about industry because I think each industry is getting more and more specific about what they want to do. In the beginning of the big Gen AI rush, as I like to call it, it was, hey, take all the content that we possibly can, and call a model and get an answer. And then as we sort of progress to customers, and I'll use insurance as an example because it's a great one. Let's take a payer. That's a really good example. A payer that may have agents and sell policies, they're really not looking to have generic answers. They're looking for something very specific and contextual to their business. And so having that capability in an easy way, for RAG-based querying matters a ton. And being able to supply that context within a specific scenario, you don't want to, send in every bit of information for every policy. It's really specific to that individual consumer or that individual agent. That really made a huge difference, both in terms of how you serve a customer, but having the right context so they're not getting hallucinations they don't need, and they're not getting information that's irrelevant to the questions they ask. And so more and more, these things that used to take hours and hours and hours are getting done in just a matter of seconds. Asking very complex questions about a policy. But then you can go one step further. What policies should I create for my consumers based on what they have, based on the questions they're asking? And so that model gets refined over and over again. I think one of the most exciting things for me is I think we're starting to see the promise of the app world turning into agentic AI or agents, right? So it's very easy to see, even based on the demo that we're going to show, how that world of finding information about specific products and substitution could easily be the next step of where you go purchase the item. So rather than do a faceted search where you're drilling down and reading all the specs, being able to ask the question, hey, is there a product with this characteristics? Oh, yes, there is. And here's how they compare. Great. All within the context of who I am as a customer and the kind of stuff I'm interested in. It just changes the way that businesses work. So I think we're going to see a very big push to doing things faster and faster with more and more information, but it's going to be an answer-based solution, not, I'm going to self-serve and drive down to get to the answer, but more like, hey, I just have a simple question. Do you have this product that looks like this? Oh, yes, you do. And here's 3 others that look like it. So it's a really exciting time. And I think Cosmos at the core of this, right? It's sort of I have always viewed it as sort of the future-proof solution, right? You want to put something in place that handles these scenarios today that we can easily define, but the world's changing really quickly. And as Gen AI gets more and more capable, and we see other AI models and data science playing into that, you really need a solution that handles all those scenarios. And I think we definitely have that in Cosmos.
Awesome. Yeah, I think thank you so much, Jerry. And one of the things which I'm really glad that you quoted about being future proof. Yes, in fact, from Cosmos D perspective, we are trying our level best to include most commonly required features, which is including full text search, and we are coming up with multiple initiatives to help with hybrid search and BM25 based indexing, and a couple of more interesting ones. I can't name it, but by build time frame we'll have more. And I think I'm pretty excited to see all those changes coming to Cosmos DB. And rest assured, the features and the functionalities which are something that you are expecting from the database, that's something that we are committed to. In fact, you are already part of it. So yeah, thank you so much, Jerry, for your time and amazing answers. It certainly helped understand the vision of Datavail and how Datavail is envisioning their Gen AI stack and how they are going to utilize the investments and the expertise you have in Cosmos DB. Thank you so much, Jerry.
Thank
And
you.
thanks. So it's time that we should switch our gears, and I'll invite Ram and Tobin. Both are from Datavail. Tobin is director and global practice leader, analytics at Datavail, and Ramakrishna is a lead AI and analyst architect. I'll let both of you to take over and help us understand your solution. And of course, we'd like to understand more about your experience and your journey in the industry. Please go ahead.
Hey, hi everyone.
Hi everyone, it's Tobin.
Hey, Tobin. And can you take it, to the next
Sure.
session, which is architecture and solution envisioning? Please.
Yeah, sure.
Over to you.
Thanks, Manish, for the introduction and for giving us the opportunity. So I'm going to cover our journey in Datavail around AI and Cosmos specifically. So to start the discussion, I'll just introduce myself. I kind of I'm director and global practice leader of data management at Datavail. My focus is helping the organization modernize their data analytics and AI capabilities using cloud-native product platforms. Over the years, I've led enterprise programs that bring together lakehouse architectures, intelligent data platforms, and AI-driven solutions to transform decision making. My work centers on aligning business strategy with scalable, secure, and production-ready AI systems that deliver measurable value. Let me also introduce my co-presenter, Rama Krishna Punapalli, our lead AI and enterprise architect, Datavail. Rama specializes in designing and implementing high-quality end-to-end solutions across data engineering, analytics, and AI. He leads the data strategy initiatives, helping customers modernize their platforms and accelerate sustainable business growth. Talking about Datavail, our organization itself, Datavail brings in deep expertise across data engineering, cloud services, and enterprise application. With over 1,000 certified cloud engineers, we help organizations modernize their data foundation, deliver AI and analytics at scale. We also optimize applications across the enterprise. Our teams support everything from integration and modernization to managed services, driving real business value through data and cloud innovation. We do have a long track record of delivering successful cloud and analytics transformations. With over 1,000 consultants, 18 years of cloud experience, and 550 plus Microsoft certification, we have helped more than 500 customers modernize and manage their data platforms. Our Azure specializations span analytics, app modernization, and data migration. We bring in deep expertise across Oracle SQL, Mongo database, Postgres, Cosmos database migrations to support scalable AI-ready architectures. We wanted to talk a little bit about the problem statement and the solution in this, what we are trying to accomplish in this session. So basically, this slide highlights how we are transforming the sales process with an intelligent assistant built on Azure Power LLM, Cosmos database, and the customer's private data itself. The user, in form of sales reps, and analysts, used to spend significant time contacting product team to find alternatives when the items were unavailable That's the kind of problem statement which kind of slowed down the entire sales cycle. That was the biggest pain point which this customer customer had. So our goal was basically to reduce the dependency and speed up the overall customer interaction, which used to take days. Our target was to reduce that time altogether. So what we built, we built an intelligent assistant engine. It's like ChatGPT-like interface that blends public LLM intelligence with private data, such as inventory, pricing, product specifications, and location. So the solution kind of delivered recommendations in under 5 seconds with a measured accuracy of around 85%. So the feedback from the client was pretty positive, validating both accuracy and speed. With that success, now the client is moving from proof of concept to full MVP implementation. A little bit more about problem statement and target solution. So as mentioned in the past slide, the overall interaction in the past was very unreliable. It was pretty manual. The turnaround times were pretty slow. Constant dependency on product and technical teams kind of increased the delay. It kind of frustrated the customer and the consumer of the data a lot. It kind of resulted in lost sales opportunities. So our target solution basically was built on Azure OpenAI, Microsoft Foundry, AI Search, Cosmos Database, and Microsoft Fabric. So it kind of combined the private data, inventory, pricing, which is kind of hosted in Fabric. You'll see that in the demo as we present it. And Cosmos Database was kind of used basically to store the chat history. Cosmos Database provides long-term memory for reasoning and improvement. AI Search handles semantic retrieval and ranking. So by integrating real-time data and intelligent retrieval, we enabled a fast, consistent, and fully trusted sales experience for the users. Let's walk through the architecture. And this slide also, in this slide, I'm going to talk about the architecture and also what you're going to see, in the demo. So on the left side, as you see, the sales rep or the user interacts through a simple chat UI hosted on an Azure web application. The requests flow securely through firewall and gateway. Authentication is handled by the Entra ID. Once authenticated, request is processed by API layer running on Azure Functions. You're using managed identity, which kind of enables passwordless access across the services. From there, system taps to AI Search and Microsoft Foundry agents to interpret the query, retrieve context, and generate the response. The private knowledge base, inventory, product specifications, PDFs, etc., lives inside the customer's lakehouse environment today. Cosmos Database plays a key role by storing the chat history as long-term memory, enabling the agent to reason, improve, and maintain context over the time. On the back end, as you see, data pipelines continuously refresh inventory and operational data every 5 minutes, ensuring real-time accuracy. Collectively, this architecture provided a kind of fast, secure, and intelligent response, end-to-end experience, enhanced experience. Now, talking a little bit about this architecture and what you're gonna see in the demo, we'll have Rama, covering. Is gonna ask 4 distinct questions, kind of posed in different ways. So user can follow up on previous questions. You'll see the chat interaction and the history overall. And there is an option also to escalate unresolved issues to support team there's a feedback part where the customers can provide the feedback whether the experience was positive or negative. You could see that in the demo. And the other aspect is the personas itself. Personas play a key role in the workflow with different types, such as sales analyst, product analyst, market researcher, product manager, and even a QA, for instance. So each persona's interaction and inquiries are tracked, enabling tailored support and efficient resolution. This kind of slide covers on why this solution is agentic. At core is have Azure Cosmos Database and AI Search work together as a tiered memory and reasoning system. Cosmos Database provides long-term memory storing past interactions, so the agents can observe previous chats, reason over them, and adapt its behavior over the time. This persistent memory is what allows the agent to learn from the analyst or the rep's feedback and improve future responses. So AI search basically is an icing over the cake. Adds advanced retrieval layer. It performs semantic re-ranking and fuzzy matching. So even if a user phrases something different, agent can still retrieve conceptually similar information. Together, these components enable the agents to decide what to do next, reference prior conversations, and refine its decision loops. The combination of low latency lookups from Cosmos Database and intelligent retrieval from AI search is what gives the system truly agentic feedback capability, moving from a simple chatbot to a continuously improving assistant. I also wanted to share one snapshot of what you will see, and Ram is going to cover during the demo. This is a sample interaction, the question as well as responses and the citations associated with the interaction. So you can see that in the Cosmos database. I'm going to talk about the challenges we have faced with this solution in the past, but how Cosmos database enables us in going through different challenges. Cosmos database isn't just a data store here. It acts as an agent's long-term memory. It preserves every chat interaction in low latency access. So it's not just storing a history. The memory layer enables, it's lightweight and it's pretty quick. On top of that, Cosmos database provides extremely fast exact lookups for the user's current session or recent messages, ensuring agent never loses context mid-conversation. And AI search layers on semantic intelligence, fuzzy matching, conceptual re-ranking, and retrieval of similar ideas when phrased differently. So the combo of Cosmos and AI search is a game changer here. So it kind of enhances from more than a traditional chatbot to an intelligent chatbot. That's the essence here. What about the infrastructure challenges? So Cosmos database helps us overcome biggest production challenges, especially when it comes to handling vector data at scale and sustaining extremely high throughput, as Jerry interacted in the past and Manish interacted in the past. Cosmos database now supports native high-dimensional vectors up to 4096 dimensions right inside JSON documents. So I don't have to kind of separately store operational data. I can, in fact, store the operational data and embeddings live together in single record. This kind of eliminates the ETL pipelines, keeps your AI responses tied to freshest operational data. So what really stands out is the ability to maintain predictable performance under massive workload. So 10 millisecond reads and write response time is great. So that kind of enables us a real-time experience. To add to that, Cosmos databases auto-partitioning automatically spreads data and vector indexes across different partitions. As the volume grows, the system a system can take care of horizontal scaling without any manual tuning. So that's the big deal. You're spending a lot of time with the other solution. But Cosmos can intelligently handle that behind the scenes. Now, when we talk about the throughput-heavy workloads, autoscale serverless mode ensures that the request units instantly adjust during surges, ideal for spiky traffic patterns of AI agents. Going ahead, what are the typical production challenges we see? One of the biggest issues we see, how Cosmos can deal with is the data fragmentation. Organization often keep our operational data in separate spaces. Cosmos the database kind of solves that by unifying both in single record, which simplifies the architecture and keeps the RAG pipelines perfectly in sync. The other major challenge we have seen is the cost of vector search at scale. Traditional RAG-based vector databases become extremely expensive, especially when storing billions of embeddings. So Cosmos database solves that with disk-ANN and disk-based vectors index that delivers sub-second performance at fraction of the cost. The platform also handles unpredictable traffic patterns with dynamic autoscale, preventing timeouts during the usage spikes and without over-provisioning. So these are some of the great features which Cosmos brings in. When this solution gets into production, we won't see that. So going ahead, this is the final slide. Just wanted to talk about how the Cosmos database especially helps in this particular solution. Customers are achieving faster sales cycle now and higher accuracy, around 85% substitution accuracy within sub 5-second responses, which dramatically improves the overall sales experience in this particular use case. And Cosmos database also enable the true agentic AI model by providing long-term memory, allowing the system to learn and improve over the time. The overall low latency performance, auto-scaling, global distribution ensure that the consistent real-time responses are in place. This kind of this solution has enhanced the overall experience in the organization, as this has been well recognized. Yeah, that's it from my side. I'll pass the baton to Rama. Rama, you wanna present the demo? Thanks.
Sure. Thanks, Tobin. That was a very good presentation. Now let's get back to the chatbot and see the actual application live in action. I'm sharing my screen here. All right. Okay. So the application starts with a login screen where any person, say for example, a sales rep, a product SME, or a marketing team can log in into the screen with this Entra ID. This integrated with Azure Entra. So here we are logging in. So it authenticates, and then we are into the application. Now it takes us to the home screen where we see a chat history of this particular user. You can see it on the 30-day chat history panel on the left side, and then you have a new chat and a home option there. So we'll start with a new chat. All right, now this opens up with some baseline questions, 3 questions we have there. This particular bot, as Tobin has already mentioned, is basically it's an application that's used for scientific instruments, scientific products that are rented out. So we will start with a specific feature or a property or a configuration of a particular product and see whether the very particular model has whether a particular model has it or not. Okay, so here the first question is we are checking if a particular frequency range is available within a particular product. Let's see what the chat response. All right, now we see that we got the technical specifications of this particular product, and it gives us the maximum frequency ranges depending on the different options that we have. All right, the first sentence says we have 10 to 3.6 gigahertz, 8.4 gigahertz, 13.6 gigahertz. So these are different options that are available for these products with different configurations. All right, now as we move, as we get this answer, right, what we're going to do is this actually is coming from chat history that you can see was previously stored within the 30-day chat history. That you can see the source here as chat history, right? So the KB chat history is the knowledge base or the chat history which is coming from the Cosmos DB, where we are saving the chat history. Now, what we are trying to do in the second question is we are trying to ask the bot a similar question, rephrasing of similar question with a little bit with a kind of summary, right, and see how it responds. All right. Now, this time, the bot responded with multiple frequency options and the range that the product offers. So this is a demonstration of within a single chat, you can also access the previous, take the context of the previous question and respond from the, using the Cosmos DB chat history. All right. Okay, now we'll follow. Now what we can do is we will start with a new chat and see whether if we are able to pick up the context from the previous chat history that we saved here. So what we are doing is we are marking this as thumbs up, which means the answer is correct, and we are marking it as resolved. So now these should be considered for our new chat when we get onto a new one. And we, in the process, we are also copying the chat ID here, because the data in Cosmos DB is stored on this chat ID, and then we'll try to retrieve it and see how it looks. It's like in real time in the Cosmos DB as we make progress in this demonstration. All right, now we're starting with a new chat. And then we are asking a similar question, a rephrased version of it. Right here, we are checking, can this particular model support measurements up to 44 gigahertz? And let's see what this chat bot responds with. All right. So now we have this response. There is an option with F44 option that extends the frequency range up to 44 gigahertz. So now we have a response, right? And we also get a key citation from the bot itself, and then a follow-up question. Would you like the inventory availability, pricing, and other? So it also asks with a follow-up question whether you want to check the inventory availability for this particular product or not. And this is also, again, is coming from the chat history from the previously stored chat. It is taking the context from the previous chat, actually. And we'll see that when we go back to the Cosmos DB. All right, now we are checking for the inventory, if the inventory is available for this particular option. And yeah, this is just a follow-up question, right? So we're just checking if particular inventory is available or not. And then I think you see the response here. No configurations of key site are currently available in the inventory, which means this particular product is not available in the real-time inventory at this moment, right? But it could be available in the future. So now what we are checking is we are checking customer needs a particular model, and we are checking what frequency range does it support, right? So we should get a response with all the frequency ranges that it should support. Yes. All right. So now we have a complete list of the frequency range support that we have, and this particular thing is coming from the configurations, which is a part of the RAG data that we have. So this shows the bandwidth available and what are the preamplifier options and other things. So it just explains the key features, what are the add-ons that needs to be done to achieve the particular what are the add-ons for this particular model ending with 544. Right. So now what we're going to do is we're going to have another question on a new chat. So now we are checking if we have a spectrum analyzer that can support 110 gigahertz. Right. So this is just another new question here. Yeah. So now we are getting this answer again from previous chat history, right? It says that it does support. It does have. We do have a model available for that. Now we're going to the next question where we'll be checking more on the inventory side of things. How would the inventory look like, and if the inventory is available for a particular product in this part. So here we are checking the availability of KTN9030B spectrum analyzer. We'll see what we get as a response. Yeah, now you can see that we have two available at two different locations with two different price ranges, right? And we have two different warehouses here, and then we have in two different warehouses we have 6 in total available, and we have a citation also on that where we are getting this data from, and what are the specific features each of these two will offer. Right. So now this is a classic case of accessing the real-time data at this instance of time, which is currently stored in Fabric Lakehouse. So yeah, this is just a demonstration of how the real-time data access would work in our scenario. And the good part here is what makes this system really reliable and agentic is that all this data is grounded, verified data. This real-time data is coming from the real-time systems. And then the Cosmos DB, which is saying the chat history, will add the agentic feature to it, by providing additional context and, future learning capabilities. So that makes it real agentic here. And that's where Cosmos really plays a key role in making the system agentic. Otherwise, the system would be just a RAG. But now with the addition of Cosmos, it's become agentic. So we are copying the chat ID here to verify in the backend. So we're marking this as resolved for now, so that once it's marked as resolved, it would be saved in the chat history as a successful resolution, and this will be considered for future references or context. Okay. Now let me take back quickly to the Foundry that was developed, and you see a list of instructions here. Now this is the orchestrator. In this current version, we are using GPT 4.1 model. And you see the instructions here. Just a quick view of the instructions, and you can also see that we have added the AI search as a tool here, and then we have two knowledge bases. It is chat history and the fabric data inventory. Fabric data inventory is the real-time inventory, and chat history provides the historical context and making it more agentic. So yeah, just this is a quick view of the instructions and how we build the agent for this bot using Foundry. Now let's get back to actual Cosmos DB. So this is our Cosmos database on Azure, and the chat history is a table that we are using to save this data. Now let's try to query the chat history table based on the IDs that we have copied earlier. Yeah. So this is the initial chat which we generated, and this is the idea of that, and we are trying to see how it looks like. Now you see here, this is the chat history. The entire chat history is saved as a array of messages, right? And then you can see that you see the role, right? The sender, the content, the issuer, and timestamp for each of this chat. And the role is basically, whether it's a user who is asking the question, or is it the AI that is responding to this message, right? And is user is true, is user is false. That means whenever AI is responding, you get is user is false, and then the sender is AI assistant. So these are the responses that we are getting from the AI and saved in the Cosmos DB. So this is how the messages are saved as an array for each chat record. And then each chat record is saved by the ID, chat ID, that you're seeing here on the left side. All right. And also it also gives the information about who the user, who created the chat, and what time the chat was created, under the context of this one. All right. Now let's also look at the second chat that we put it in the Foundry. Look at the other record. You can also see a similar pattern there, but it's a smaller chat because it was only one question. So we'll have a smaller chat, and we can see how it would look like, because this is the one that provided us the inventory data response. Yeah. So now we see here we have a check the availability of KT 9030 spectrum analysis. So this is the same question which we posted for availability, and now you see the content in the second message. The content is the response that we got from the system. We can match it. It's exactly the same. So we are saving that response here in this record. So this is how the chat history is saved in Cosmos DB, and then further it is utilized in the next chat. Right. So again, we have the same user, the timestamp, the message information here. All right. Now let's get back to the AI search side of it, how it was, how the indexes are created on the AI search for Cosmos DB. So first thing we have to do is we have to add the Cosmos DB as a data source to the AI search, so that we can create indexes on top of it. So this is the Cosmos DB that we have added as a data source here. All right. Thank you all. That's all from my side. Please let me know if you have any questions.
Thanks, thanks, Robin. I do have a couple of questions which I would like to ask on behalf of the audience. So, one of the question is, how does AI board got real-time inventory data?
So real-time inventory data is stored currently in Fabric Lakehouse. We have a near real-time refresh of this data from real-time replica systems. So that way we have data as real-time as 5 minutes old. So that's how old the data is. That's the latest, and then it is stored in Fabric Lakehouse, and then we are accessing it as a knowledge base um, in the Foundry to access the data, and then we are using prompts on top of the data to filter out the data and then put guardrails around it.
Superb. That's really helpful because the existing data will certainly make more sense here. Now, because you are going to get a lot of data from lot of dimensions, and the inputs are coming from multiple angles. I'm sure that you would have come across this many times. Uh, how how have you handled hallucinations in the solution?
Yeah, hallucination is a very key aspect that we need that for any AI system. So the one of the good part here is we are using grounded data, right? The real time data is really it's grounded, and then the configurations data that we are using are coming from the configuration documents for the products. So that's again verified and grounded by the SMEs. So because of that, the level of hallucination on the real-time inventory data and PDF documents is very minimal. On top of it, we are also using guardrails, and we are controlling the hallucinations through the prompts. So they are guardrails is a very key aspect here, and defining the guardrails uh, to reduce the hallucinations is helping us here.
With guardrails, it is basically agent instructions. We kind of we have it very clearly. It's part of requirement gathering of the project. We have to kind of write it based on what customer needs are. So that kind of reduces the hallucination.
Awesome. Thank you so much. It was really nice and interesting session. And I really like the demo uh, part. Thanks, Ram. Thanks, Robin, for your time. It was lovely catching up with you. Thanks a lot, guys.
Thank you, everyone.
Thank you.
And today I'll demo Query Insights with the GitHub Copilot integration in the Document DB for VS Code extension. Query Insights is part of the Document DB for VS Code extension, and it helps me find performance bottlenecks and to fix them. Let's get started with a quick example. Here I have a sample database with store data and historical sales aggregates. Let's start with a simple query. I'll filter stores in just one city, Port Auto, and let's make it more specific and look at revenues greater than 40,000. I run the query and we can see there's only one document in the result that matches. Now, I'll open Query Insights to see what's happening. Query Insights helps me understand the performance of this query. I can see it took roughly 40 milliseconds to execute, and it had to examine about 40,000 documents to return just one result. That's not great. Query Insights highlights the key stats and gives me a clear overview of query efficiency and a performance rating. Next, I can explore the query execution plan, and I can also view the raw details. Now let's focus on how Query Insights can help. The next step is to ask for AI performance insights. It gathers stats about the collection, indexes, and the query execution plan. Then it uses GitHub Copilot to return not only a performance summary that's easy to understand, but also the actionable recommendations. In this case, it recommends creating a missing index. I'll apply that recommendation. Now let me rerun the query. The execution time improved significantly. Only one document is examined. The performance rating is excellent, and in the details, I can see an index scan was used. So that's Query Insights in action. It helps me find the bottleneck and to fix it.